Section 3.4 Exponential and Logarithmic Equations. Success is not final. Failure is not fatal. Courage to continue that counts. Unknown. So the previous 3 sections we talked about exponential and logarithmic equations and their properties. And so today we'll be discussing how do we solve these type of equations. So the properties that we'll be using quite a bit are the one-to-one properties here. So this is for exponential equations. If the base is the same, then we can set the exponents equal to each other. And this is for logarithms. If the log has the same base, then we can set x is equal to y. And then we're also going to look at these inverse properties. So if we have exponential raised to a log with the same base, then our answer is just x. And if we have a log with the base of an exponential with the same base, then our answer is just x. So to solve these equations, first, we can rewrite the equation in the form b raised to the n power equals b raised to the n power. If we can write our equation in this form, then we can use the one-to-one property and set, in this case, the exponents equal to each other, m is equal to n. Then we solve for the variable. So for example, here we have 5 raised to the 3x minus 6. 125 I can rewrite as 5 cubed. 5 times 5 times 5 is 125. And now they have the same base. So I can set my exponents equal to each other and solve for the variable. So I'm going to add 6. So I get 3x is equal to 9, divide by 3. So x is equal to 3. Okay, so we have to use these properties in order for us to solve for x, since x is an exponent. So let's look at letter B. For B, we have 8 and 4. So what we can write these as, it would be 2 cubed for the 8 and 2 squared for the 4. If we have an exponent raised to another exponent, then we multiply. So this is going to be 2 raised to the power of 3 times x, which is 3x, and 3 times 2, which is 6. And on this side, we get 2. 2 times x is 2x. 2 times negative 3 is negative 6. So now we can set the exponents equal to each other and solve for x. So I'm going to subtract 2x. So I get x. I'm going to subtract 6 is equal to negative 12. And you can check your answer. If you plug in negative 12 in for the x on both sides, then you'll see that you get an equivalent equation. Okay, so let's look at letter C. Here we have the base e and the base e. So it's the same base. So we can set negative x squared equals to negative 3x minus 4. Notice that the x is squared, so that means this is quadratic. So everything should be on the same side. I'm going to bring x squared on this side. So I get 0 is equal to x squared minus 3x minus 4. And now you have choices to solve this quadratic equation. You can either factor if it's possible, if it's factorable, or you can use the quadratic equation. So I'm going to test, see if it's factorable. So 4 would be 4 times 1. The 3 is negative, so the larger number should be negative. So this does factor. So I can set each factor equal to 0 and solve for x. So in this case, we get 2 solutions. And letter D, notice that we have 4 to the x is equal to 15. Well, we try to change 4 and 15 so that they have the same base. That's going to be impossible. So what that means is that this method does not work for this problem. Okay, so this method does not work for every problem that we have. So we need a different method. So here we have isolate the exponential steps for solving exponential equations. Notice it says with unlike bases. So the first thing we're going to do is we're going to isolate the exponential expression, multiply the common log on both sides, simplify using one of the properties that I have listed over here, and solve for the variable. So if you notice, this is my exponential part, and it is by itself. So we can go to step 2, which is to multiply by the common logarithm, or you can multiply by the natural logarithm. So I'm going to go ahead and multiply by natural log of 4x is equal to natural log of 15. So we have to multiply it on both sides. Now we can apply one of these properties, and the property I'm going to apply is we can use the power rule and bring the x to the front. So I can use this property here. So I'm going to have x natural log of 4 is equal to natural log of 15 divide by natural log of 4. So we get x will be approximately, so we can use our calculator, and we have natural log of 15 divided by natural log of 4, enter. So this is approximately 1.953. Okay, so let's go on to the next one. Number 5. So first you can check, can you make 134 have base 5? And in this case we cannot. So we're going to multiply by natural log on both sides. I'm going to use the power rule and bring the x to the front since it's an exponent, and divide by natural log of 5. If you're using WebAssign and it wants an exact answer, then you would enter natural log of 134 divided by natural log of 5. If it wants a decimal, an approximation, then you can put that in your calculator. Natural log of 134 divided by natural log of 5. And the answer would be approximately 3.043. For letter C, we have 10 raised to the power of x. So you can still use natural log, but notice that the base is 10. So I'm just going to use the log with base 10. So we can bring x to the front. Divide by log 10. Until we get x is equal to log 8,000 over log 10. That's your exact answer, the approximation. $3.903. And if you use natural log, you would still get the same answer. Natural log of 10 to the x is equal to natural log of 8,000. Bring the x to the front. Divide by natural log of 10. Put it in the calculator. And so we get the same answer. So you can use natural log or logarithm, whichever log you prefer. Let's go to the next page. So for example 3 here, notice that the exponential part is this right here, and it's not isolated. So one of the steps was to first isolate the exponential expression. So I'm going to add 4 on both sides. And I'm going to divide by 2. And so now I have my exponential expression isolated. I can take the natural log on both sides. Use the power rule to bring the exponent to the front. And now we can solve for t. Okay, so I'm going to divide by natural log of 3. And I'm going to add 5 on both sides. Plus 5. And I'm going to divide by 2. Okay, I'm going to enter that into our calculator. So we have natural log of 15 divided by 2 divided by natural log of 3 plus 5 divided by 2. And so that's my approximation. Let's go ahead and try the next one. Letter B. So again, for these problems, you want to check if you can make these bases the same, because that's always going to be the quickest way. If you can't, then we have to apply the second way of doing this. In this case, we cannot, so I'm going to multiply by natural log on both sides and apply the power rule, so I'll bring the exponent to the front. And I need to solve for x. So here I'm going to multiply natural log of 3 into the parentheses. So natural log of 3 times 2x minus natural log of 3 is equal to x natural log of 7 plus natural log of 7. Put all the terms with an x on one side. So I'm going to add natural log of 3 to both sides. And I'm going to subtract x natural log of 7 on both sides. So now I have 2x natural log of 3 minus x natural log of 7 equals to natural log of 7 plus natural log of 3. Notice they both have an x in common, so I can factor out an x. Once I factor out an x, then I can divide by the coefficient here. So I get x is equal to natural log of 7 plus natural log of 3 divided by 2 natural log of 3 minus natural log of 7. So the approximation for this, if you enter in your calculator, is going to be 12.11. Okay, so let's look at those were exponential. Now we're going to look at steps for solving logarithmic equations. So one of the first things we want to do is is to check the one-to-one property. If log bm is equal to log bn, then m is equal to n, so we can solve for the variable. If you cannot use the one-to-one property, then we want to express the equation in the form as follows. If you have this log bm equals c, we want to make sure it looks like this. Once you have it like this, then we can write it as an exponential equation. And so this, if we rewrite as exponential, will become b raised to the power of c equals m. Once we have it that way, then we can solve for the variable. And then you want to check your solution. The expression for m in here must be greater than 0 because of the domain. So let's look at example 4. We have log 3, 5x minus 1, log 3x plus 7. Notice here that the base is the same. So I can use the one-to-one property, which tells me that I can set f 5x minus 1 equal to x plus 7. I'm going to subtract x. So I get 4x, and I'm going to add 1. So we get that x is equal to 2. We need to check our work, or check our answer. Okay, so if I check my answer, I'm going to have log 3 of 5 times 2 minus 1 is equal to log 3 of 2 plus 7. 5 times 2 is 10 minus 1 is 9. Notice that the 9 is positive, so we're good there. And 2 plus 7 is 9. So here again, we get it to be positive. So that means that x equals 2 is the solution. Okay, let's look at the next example. So here it's not set up as one log. In fact, it has 3 logs. So, however, they all have the same base. So if we can somehow have one on this side and one on this side, then we can use the one-to-one property again. And so let's try to combine these with our properties from 3.2. Since I'm subtracting here, I can put these together as division using the quotient rule. And so now I'm left with just 2 logs with the same base. So I can set x minus 3 is equal to 7x minus 23 divided by x plus 1. Multiply x plus 1 on both sides. So x times x is x squared. 1 times x is x. Negative 3 times x is negative 3x, and minus 3. Gather like terms. This is quadratic, so all the terms should be on one side. And so now we can try to factor, or we can use a quadratic formula. So here I'm going to have minus 4 and minus 5 are my factors. And I can set each factor equal to 0. So x is 4 and x is equal to 5. We need to check our solution. Okay, so we have natural log of, let's check 4 first. 4 minus 3 is equal to natural log of 7 times 4 minus 23 minus natural log of 4 plus 1. 4 minus 3 is 1. 7 times 4 is 28 minus 23 is 5. Natural log of 4 plus 1, that's natural log of 5. So they're all positive. Okay, so that's okay. And then for 5, if we plug in 5 in here, 5 minus 3 is 2. That makes it positive. 7 times 5 is 35 minus 23. That's going to be positive. And 5 plus 1 is 6, which will make it positive. So both of these are going to be our solutions. Okay, let's try letter D. Notice here I don't have two logs, so I cannot use the one-to-one property. However, this looks exactly like this form. So I'm going to go ahead and change it to exponential. So my base here is 2. The log is always equal to the exponent. So this log is equal to 3. So that makes 3 the exponent of x minus 4. 2 cubed is 2 times 2 times 2, which is 8. Add the 4 on both sides. So we get 12. Don't forget, we need to check your answer. So 12 minus 4 is going to be positive, so that's okay. Let's go ahead and try the next one, letter D. So here we also need to isolate the log here before we can change it to exponential. So I'm going to divide by 4. Remember that the natural log is the same as log E. So my base here is E. The log is equal to my exponent, in this case 2, of 3 to the x. Divide by 3. So E squared is equal to 3. Divided by 3 is my solution. The approximation, if you enter it in the calculator, is 2.463. So if I enter it on the calculator, I get second E raised to the power of 2. And I'm going to divide that by 3. And so we get 2.463. Letter E. So we have log x. So here we can combine these two logs. Since they're being added, I'm going to multiply them. And I'm going to change this to exponential. So my base here is 10. The log is equal to my exponent. So x times x is x squared minus 3x. Bring the 10 over. You can try to factor or use the quadratic formula. Set your factors equal to 0 and solve for x. Check your solutions. If you plug in 5, that's positive. 5 minus 3 is still positive, so that is a solution. If I plug in negative 2, I get log of a negative number, so that's not a solution. And then the last problem here, subtract by 7 on both sides. Divide by 3. So here the base is e, and it's raised to the negative 2/3, since that's what the log is equal to. So we plot that in the calculator. We get second e raised to the negative 2 divided by 3, 0.5134. And the last question for this section, how long to the nearest tenth of a year will it take 1,000 to grow to 36,000 at 8% annual interest compounded quarterly? So in the previous section, we saw the following formula. So APRMT. So how long will it take 1,000? So that's your principal to grow to 3,600. That's your ending balance at 8%. That's going to be R. Annual interest compounded quarterly. So that's going to be 4 for compound quarterly. And then T is what we're looking for. Okay, so I'm going to divide by 1,000. And then we can simplify this in here. So we have 0.08 divided by 4 is 0.02. So we get plus 1 is 1.02. And of course, 3,600 divided by 1,000 is 3.6. So now this is isolated, so we can multiply by natural log on both sides. Use the power rule. And solve for t. So I can divide all of this by 4 natural log 1.02. So t is equal to and the approximation, if you enter that into your calculator, comes out to around 16.17. So that's the end of this section.